right, let's run through another question from Princeton's Physics 101 final exam review. This one says, what is the speed of a satellite with mass of 1 times 10 to the 4th kilograms on a circular orbit around the moon at a distance 4r, the radius of the moon, from the moon's surface? So for this, we're going to need two equations, which we're going to relate to each other and then try to solve for a velocity. Those two equations are the force due to gravity equation and the centripetal force equation. So velocity is what we're going to be looking for. And the centripetal force equation has velocity in it, but we don't know the centripetal force. So we won't be able to use this equation, but we can use a combination of these two equations because the centripetal force is going to have to equal the gravitational force. Because the centripetal force, by definition, is the amount of force that it takes to maintain a circular path. And the force due to gravity is the force that that satellite experiences. So the centripetal force, the force keeping the satellite in orbit, is the gravitational force. So if we can actually set these two equations equal to each other. After I set these equal to each other, what we're going to try and do is solve for velocity, and then hopefully we'll be able to plug in the rest of the variables. So first I can divide both sides by m, because there is a small m on both sides, which is going to be the mass of the satellite in this situation. And that's going to cancel out our m's. Then I can multiply both sides by r to get rid of the r on the right side, and that's going to cancel out the squared from the r on the bottom here. Then if we square root both sides, it's going to cancel out the squared on this side and the square root. And this is going to be our equation for velocity. So v equals the square root of g times the mass of the moon, which is another value we can look up, divided by the radius, which is the distance from the center of the moon to the satellite. And it says the satellite is 4r, so 4 radiuses of the moon away from the surface of the moon. So we actually have to add in the radius of the moon because we're not measuring from the surface, we're measuring from the center of the moon. So there's one more radius of the moon. So r here would actually be 5r, or 5 moon radii, which we can also look up. So plugging in all these values, we're going to take g, which is the gravitational constant, which is 6.67 times 10 to the negative 11th. And the units are meters cubed over kilograms seconds squared. We get the mass of the moon, which is 7.35 times 10 to the 22nd kilograms. It's a pretty big moon. And that's going to be divided by 5 times the moon's radius, which is 1.74 million meters. So 1.74 times 10 to the 6th meters. So when we do out all this math, we get a velocity of 751 meters per second.